I welcome all of you again to my class, and today we will be using this, just like I told you. These are cubes to solve a perfect square quadratic equation. So most of you might be thinking that, what are these for? Okay, so these are small cubes. You can actually use it in teaching so many mathematical topics like shapes and the rest of it. So I can use it to form shape, just like you can see here. I can use it to form different shapes. Most of you already know the game that bears these shapes. So I can use this to form shapes and then play games with my students, or I can use it to form so many other things like this. So, but today we are not going to be using it to play any other game, but we'll be using it to solve quadratic equation, which is a hands-on activity style of learning how to factorize a perfect square quadratic equation. So we begin, just like you can see our quadratic equation, perfect square quadratic equation already here. So I have already shared it. Just if you have watched my last video, you understand where we have used this. So s power 2 is represented by 4 cubes, and I'm multiplying it by 1. Reason, because the coefficient of x here is 1. So 4 cubes representing any variable with power 2. They're multiplied by the number of coefficients it comes with. This is a 6x. Every variable x, or a variable with power 1, is represented by 2 cubes, then multiplied by any coefficient it carries. So that is why I'm multiplying it by 6. So meaning I'm going to be using 12 cubes here, but they are going to be in twos, just like you can see here. This is in twos. I've just stacked it together. So this is representing variables x with raised to power 1. So as you can see here, you have it up to 6 of them. Likewise, this is representing the x square variable with the power 2. So that is 4 cubes. I have already tacked it together. Then we have the constant. We have 1 cube representing each constant, and then we have a constant of 9. That is why I'm multiplying the single cubes by 9. So we have a total of 4, 12, and 9 single cubes to be used. So we'll begin our calculation. So how do we use this to solve this quadratic equation? Very simple. Now, this is what we are going to do with this. So now we begin our calculation. I am picking the x power 2 first, and I'm going to use the 6x, that is the cubes, two cubes up to 6, to wrap around this x squared. But I'm not going to cover every aspect of the x squared totally. So I'm going to leave the space here, 2 spaces. I'm going to use it to cover it round. Please, you do not cover the entire. Make sure that when you're placing this, that it doesn't cover an entire color, an entire space of color. There are reasons why we say that. So it will be easy for us to identify our answers at the end. So I am going to use this. Watch how I do that. So you can see what I have done. You can all see what I have done. Remember, we're working with the perfect square. We are supposed to be using this to create perfect squares. In case this, you have just like a space left, this is still there. So this can fill the space up, and then you continue forming the square shape. So the last one, that is the constant 9. So I'm going to do the same here. I will use it to wrap around. Remember, you don't cover the entire space of any color. All right, I have formed a square shape. So if we want to check, we can confirm. We have one single, let's count single cubes. We have 1, 2, 3, 4, and 5. 5 this way, and we have 1, 2, 3, 4, and 5. So we have 5 single squares on each of the spaces. It is time for us to read our answer. Okay, so when we are reading our answer, now watch this. You see, this is together. This marks X. It is not separated. That is why I tagged it together. So I can read from different angles. I can read from here because at this particular angle, you can't see the other cubes are not visible here. I can read from here because the other cubes are not, the other ones representing X with an X are not visible here. So I can read from here. So if I separate this, you can see it's intact. Then I will check how many intact value do I have here? How many intact cube can I see from this angle? Very, very important. How many can I see from this angle? We are looking at the eyes. How many can I see from this angle? We can see 2. We can see 2 intact, and we can see single, single, and single. So we have 3 singles. 3 single cubes here. Likewise, when I see from here, when I see from this angle, what am I seeing? I am seeing 2 intact cubes, and then I am seeing single, 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 making a total of 3 single cubes. We remember that 2 cubes represents the constant, the variable X. So if I can see 2 cubes from this angle and I see 2 cubes from this angle, say, what does it mean? It means that these 2 cubes will also take what it represents. It still represents what it represents, which is X, whereas this represents the 3. Are you getting me? This represents 3 single cubes, which is a constant. Single cubes are constant, whereas 2 cubes is representing the variable with X, not the variable of X power 2, the variables with X. So there, from here, I have X and 3. And likewise, from this other angle, I have X and 3. Remember, you read from both sides where you can see visibly the shapes for the X power 2, the X, and then the constant. So at this point, if you look at here, I can see X and 3, so which gives us X plus 3. And then from this angle, you can still see the same X and 3. X represented by 2 cubes intact, and then 3 single cubes. So therefore, if this is what this gives us from both angles, from here and from here, therefore, our result after factorization is X plus 3 and X plus 3. That is our answer. Remember to click the like button